Okay, this is the second video for test review corrections. Please make sure that you are writing down everything. And you have to, even though it's a multiple choice test, you have to write it down as if it were a free response. Okay, so the caffeine content of 8-ounce cans of a certain cola drink is approximately normally distributed with a mean of 33 milligrams. A randomly selected 8-ounce can containing 35 milligrams of caffeine is 1.2 standard deviations of the mean. What percent of 8-ounce cans of cola have caffeine content greater than 35? So here's my picture. So first off, we know we're centered at a mean of 33, and we have this can that is at 35. They didn't give us a standard deviation, and they want to know the probability that it's greater than 35. So that's what we're looking for, is the probability is greater than 35. Now, my z-score associated with that is 0, and my z-score associated with this is 1.2. So really what I'm looking for is I'm looking for the probability that x is greater than 35. And I'm also could be looking for the probability that z is greater than 1.2. Well, with the x, I sit there and write down, I go, okay, we have a z equals x minus mu over sigma, and I start plugging in, and I notice what I don't have. What I have with the z-score, which makes this really nice, is I know, well, let's talk about the mean. With the mean, we have a 33, we have a 35 as my x value, and I have a standard deviation that I don't know, but I do happen to have a z-score that's just 1.2. And so I can go about and solve this, and this would be, this ends up being swapping places, and my standard deviation is 35 minus 33 over 1.2. 35 minus 33 divided by 1.2, and I end up getting 1.6667. So my standard deviation is 1.6667. And then I can do a norm CDF, and my lower will be 35. My upper will be infinity. My mean is 33, and my standard deviation is 1.6667. All right, so plugging that in, second bars, norm CDF, lower bound, 35, upper bound, loading that up with a bunch of 9s, mean of 33, standard deviation 1.6667, and I end up getting about 12%. I get 11.5. So this ends up being 12%. There's a shorter way to doing that, though. We have the probability that z is greater than 1.2. So I could do second bars, norm CDF, lower bound 1.2. My upper bound is infinity. If we're talking about a z-score, we can plug in a mean of 0 and a standard deviation of 1, because all z-scores are like that. And we end up getting the same 0.115, and my closest answer is 12. Okay. Right, so either one of those would have been fine. This is the long way. The short way would have been to set up a z-score, which would have been saying, hey, you know what? 0, 1.12, or excuse me, 1.2, and then our standard deviation is 1, because every z-score has that. So you could have gone at it that way as well. All right, number 9. The probability of a head, obtaining a head when a certain coin is flipped is 0.65. So the probability here is not consistent. It's not a fair coin. So the probability of a head is 0.65. Which of the following is closest to the probability that heads would be obtained 15 or fewer times when the coin is flipped 25 times? So zero, we could have 0 heads, 1, 2, ... 14, 15, 16, ... And we're flipping it a total of 25 times. What's the probability to be obtained 15 or fewer? That means I'm looking for that entire group. So we have a fixed number of trials, which is 25. We have a fixed probability of 0.65. So this means we're working with a binomial CDF. So in this case, our work would look like this. We have to show that some of the PDFs, which would be the PDF of 0 plus the PDF of 1, all the way to the PDF of 15. So this would be 25, choose 0. Our probability of a heads was 0.65, getting 0 of them, and then 1 minus 0.65. 25 minus 0 is 25, plus ... plus 25, choose 15, 0.65, excuse me, 0.65 to the 15th power, 1 minus 0.65, 25 minus 15 is 10. So that's my work shown. What I'm plugging into the calculator is this, and this is the work that I need to show to receive credit. Then for the calculator part, it's going to be since we have the lowest value, we don't have to do a 1 minus. So we're just going to do a binom CDF trials. How many trials did we have? We had 25 trials. Our probability of success is 0.65, and our X value in this case was 15. So here we go. Second vars, binomial CDF trials 25, P 0.65, X value 15. And we get 0.036. So equals 0.3696. And our closest answer is letter B. Okay. So next one, a certain type of remote control car has a fully charged battery at the time of purchase. The distribution of running times of the car of this type before they require after its initial purchase is approximately normal with a mean of 80 minutes. So this is 80 minutes. And with standard deviation of 2.5. The shaded area in the figure represents which of the following probabilities. Well, 80 plus 1 standard deviation means this is 82.5. And this is going to be, this one is going to be 80 minus 2 times 2.5, which is 75. So our description here is this is running from 75 to 82.5. We also know that this value right here would be at 87.5. This would be at 85. That's at 87.5. This would be at 72.5. And not that it asked me to do this, but if it had asked for z-scores, this would be a z-score of 0, 1, then 2, then 3. This would be -1, -2, -3. All right. And the answer is the probability that the running time of a randomly selected the car before it requires recharging the battery for the first time after its period of initial use is between 75 and 82.5 minutes. All right. So because we're interested in this area, which is 75 to 82.5. All right. So that takes care of number 10. Number 11. R is the value of the data set that has a z-score of -4, -1. S is the value of the first quartile, and T is the value of the 20th percentile. Which of the following is the correct order for the least to greatest values of R, S, and T? So I actually have several choices. I can convert these all to z-scores, or I can convert them all to percentile ranks. Well, since I already have two that are kind of in percentile ranks, I'm going to go that route. So this is going to be 0.20. This is going to be 0.25. So I need to convert this one. Well, since they gave me a z-score, I can do that means I have this, mean of 0 and a -1. And I can do a norm CDF with a lower equal to -infinity, an upper equal to -1, a mean is 0, and the standard deviation equal to 1. So when I do that, I go to the calculator, second vars, norm CDF, lower is -infinity, upper -1, mean is 0, standard deviation 1, and I end up getting 0.1586. So this equals 0.1586. And they want least to greatest, so that means smallest to largest. So 0.15 is going to be R, so R has to be the first one. And then the next one needs to be T. So letter B is my choice. Alternatively, I could have turned these all into z-scores, and I could have done that by going to, since we already have that z-score, I could go to 0.25 by doing an inverse norm. Second vars, inverse norm, 0.25, mean of 0, standard deviation of 1, and I end up getting a -0.67. So this is -0.67. And then do the same thing for this one. Second vars, inverse norm, 0.2. And I get a -0.84. And if I were putting those in order, it'd be -1.0, then -0.84, and then -0.67. Smallest being R, next smallest being T, then S. Same thing, just different way to approach the problem. Number 12, a recent study was conducted to investigate the duration of time required to complete a certain manual dexterity test. The reported mean time was 10.2 seconds with a standard deviation of 16 seconds. All right, so we have a mean of 10.2, a standard deviation of 16. Suppose the reported values are the true mean and standard deviation for the population of subjects in the study. If a random sample of 144 subjects is selected from the population, so n equals 144, what is approximate probability the mean of the sample will be more than 11 seconds? So we're looking for the probability that the mean will be more than 11. So that means we're looking for probability that X bar is greater. So that means we're working with Z equals X bar minus mu sigma divided by the root of N. So I need the probability that Z is greater than 11 minus 10.2 over the standard deviation. And once again, I know this is multiple choice, but you're going to have to show this for here, just like you were doing a FRQ, and that's the probability that Z. This is where you want to go to Z-test. So you're going to want to use Z-test for this. And our mean is going to be 10.2. Standard deviation is going to be 16, N is 144. So here we go. Stat test, z-test, mean 10.2, standard deviation 16, X bar 11, N 144, and make sure we have a greater than. So we want the probability that Z is greater than 0.6, which equals 0.2742. And in that case, our best answer is going to be letter B. All right. Number 13. Based on the values of the true mean and true standard deviation, it can be concluded that the population distribution is not normal, and therefore the probability cannot be calculated. A distribution of test scores is not symmetric. Which is the best estimate of the z-score of the third quartile? Well, wait a second. So they told us it's not normal. It's not symmetric. I can't use any of my normal calculations. Because I can't use any normal calculations on this particular problem, I can't even calculate it. So this z-score cannot be estimated. In other words, I can't, because normally what we would do is we'd go to, oh, this is easy. If it were normal, and there's say third quartile, and you go, all right, I know that's 0.75, and I can get a z-score doing an inverse norm. But they just told us it's not normal. So consequently, we can't use an inverse norm. And if the distribution is not symmetric or not normal, then a distribution cannot be normal, and we cannot use our knowledge of the normal to convert to a probability of the z-score. This z-score cannot be estimated. All right, so E is the answer. You can't estimate that one. Finally, number 14. A distribution of scores is approximately normal with a mean of 78 and a standard deviation of 8.6. So we have a mean of 78, a standard deviation of 8.6. Which of the following equations can be used to find the score X above which 33% of the scores fall? Be really careful. So it says, so anytime they have something like this above which 33% or below which, I make an X and it says, oh, this is above, so this is telling me that I need 0.33 and I need this 0.33 right here. Well, that's a little bit of a problem because your calculator works from left to right, which means this area right here is 1 minus 0.33, which is 0.67. All right, and we're plugging in z equals x minus mu over sigma. So we're going to plug in what we know. And what we know is the mean. We know the standard deviation is 8.6. We're looking for x. We're looking for that value. But they say 33%, but remember, we're having to work left to right, so it's going to be the 0.67. So I'm just going to do an inverse norm of that to get a z-score. So second vars, inverse norm, getting the z-score 0.67, mean a 0 standard deviation of 1. And we get a z-score of 0.4399, in which case we could solve by algebra if we wanted to, but there we go, 0.44. All right, and that's our answer, and that's the that takes care of everything. So this right here has a z-score of 0. This has a z-score of 0.44. And if I wanted to, I could solve this by algebra by multiplying it by and adding 78. We end up with 81.78. They didn't ask, I didn't specifically have to give that information because they wanted the formula, but there you go. All right. Thank you for watching. I hope this helped.